All right, so I have started recording. So what we're gonna do here in this session is a small little crash course review for your midterm tomorrow. So let's just start by highlighting what should be on the midterm tomorrow and give you a good idea of what we're gonna cover. So your midterm, as Dr. Tala says, it's all of the content that you've seen in class up to now, right? So that would include some project management theory. You have earned value management, that chapter. You have project scheduling, which that actually came before earned value management. And then you have the more mathematic economic portion of the course, which is the time value of money, cash flow analysis, and economic equivalence, which we have seen in class up to now. So this crash course, it's gonna cover this portion here, the mathematical equivalencies, which is the bulk of the economics that you've seen so far. If we have some more time, we might do some earned value management. But other than that, project scheduling and the project management theory will not be covered here. So you might have to review your theory and the scheduling on your own time to be fully prepared for the midterm. Okay, so with that being said, we're gonna get started. So for this crash course, we're mainly focusing on covering tutorials 7 and 8, which are for lecture 6. Okay, so let's go to tutorial 7. So tutorial 7 is cash flow analysis. And here is the first question. It says, how much should you invest today at 12% interest rate to accumulate $1 million in 30 years? Okay, so let's start with what we know. We know that the interest rate is 12%. And we know that after 30 years, we want to have $1 million, right? So 30 years in the future, we have $1 million. So $1 million is a future value, which we write as F, future value, $1 million. And it's 30 years into the future. So this question doesn't provide any outward information about how the time is compacted, how the interest is compounded. So we will assume that it's yearly. So we have 12% yearly interest compounded yearly for 30 years. Now, that means that our N is 30 because we will have 30 years, 30 periods. So the question here is, at an interest rate of 12%, you have to invest a certain amount that 30 years later, it will accumulate $1 million. So what is the starting amount? Okay, let's look at our formula sheet, which we have for this class. Here is our formula sheet. You have all these formulas, which helps you convert between values in different time frames. You have future worth, present worth, and annual worth. And then at the bottom, you have tables. I'll show you how to use both of these. But anyway, let's start with trying to use a formula here. What is the formula that allows us to find a p-value given an f? So we are transferring f to p. So the trick with these formulas is to look at the letters. Pay attention to the part of the formula in the beginning, in parentheses, where you have a letter slash another letter. The first letter is what you're trying to get, and the second letter is what you have. So this formula converts a present value into a future value. And this formula is the opposite. This formula turns a future value into a present value. So always the first letter is what you want, second letter is what you have. Okay, since our present value here is an unknown, we can just use any of these two formulas. One is just the inverse of the other, and we can solve for our p. So let us write the formula. So the formula we have is the future value is equal to the present value, 1 plus the interest rate to the power of n. And notice how we have everything except for our p-value. So all we have to do is plug in our values and calculate p. So we have $1 million we want to end up with, p, which is unknown, at 1 plus 0.12 interest to the power of 30. And all that is left is to calculate the value of p. So if you do this calculation, you get p is equal to $33,378. Okay. So what if we wanted to use the formula or the table? So keep in mind that the formula we used here is f is equal to p of f slash p, because we want an f from a p-value, I to the n. If we want to use the tables here instead, keep in mind our interest rate is 12%, and we have 30 periods. So we will find the table at the top left, it says the interest rate. So find the table that represents 12%. It's over here. And the 30th period. So this table only goes until the 20th period. Just a second. I believe there is another version of the formula sheet that has tables going until the 30th period. But we can save that for another question. But this is how we do it based on the formulas. Okay. Let's move on to question 2. And so the recording will be uploaded, depends just how long it takes to upload, because it's going to be a kind of a long recording. So it will be made available as soon as it gets uploaded. Yes, Mustafa, you have a question?
Uh, yes, Matthew. Could you please go back to the formula sheet if I didn't, probably I didn't understand a part. I still doubt that why can't we use the last formula, which is the present worth factor? Because you said the first letter is what we want, the second one after the slash is what we have. For example, what we have right now is the F, the future value. I'm concerned why can't we use the last formula instead? Future value is $1 million is over the period of the N 30 years and with the interest rate of I, which is 12%. So
Right.
why can't we use 1 over 1 plus I in the power of to the power of N?
Right. So you absolutely can do that. It's just another way of solving it. So we did it this way with this. The We use the F slash P formula. If I
Oh,
want,
okay.
I
Yeah,
can calculate my present worth, which is equal to the future value P slash F at 12% for 30 periods.
I see.
And with the known F, which is $1 million,
So that's another way
this
in
will
the
give the same result.
so
Exactly.
could you and my last question, could you please show us if you want to just refer exactly the notation you had? If I want to find it on the table, I still have some difficulties working with the table. Can you just
Right.
find this one, for example, on the table? Assume that it's over 20, which is our
Okay.
last value.
So if we had 20 periods,
Yeah.
we would go 12% interest rate here,
Uh-huh. Okay.
20 periods, and we would use these are the two factors. So you have, if you want to use P slash F as you did it,
I see.
this P slash F here, you would take this factor, which is
Ah,
zero
I
point
see.
0.1 basically, approximately zero point 0.1, and you would say that this here is equal to zero point 0.1. That's not accurate, right? Because it's for
Okay. Yeah, I
20 terms,
understand.
not 30,
20
but
times. I
assuming it
understand.
was, you would, so then you would multiply the $1 million by that factor, zero point 0.1.
I see. I see. So the entire term inside the parentheses is going to be equal to the value found in the table.
Exactly.
Okay, that was my difficulty that I got the answer. Thank you very
Mhm.
much. Thank you.
No problem. Okay, let's move on to the next question. 3.9. So it says, how much is accumulated over 2 years in each of the following savings plans? So let's start with A. It's $40 at the end of each month for 24 months at 12% compounded monthly. Okay, so let's start with what we know here. 3.9 part A. So anytime you have a reoccurring payment, you get $40 at the end of every month. Anytime you have a reoccurring payment like this, we call that value A. So we'll write capital letter A is equal to 40. A stands for annuity, uh, but it doesn't have to be on a yearly basis. Any reoccurring payment over a consistent period, we call it A. Okay. Then it says for 24 months at 12% compounded monthly. Our nominal interest rate here, which I will write by the letter R, is 12%. Nominal interest rate means it's for the year, 12% per year. However, in this problem, it's compounded monthly. The calculation is done monthly. What that means is that when you have this calculation compounded monthly, it means that every aspect of our formula we will use needs to be adjusted to the month. So the interest rate must be the monthly interest rate, and this n periods must represent the amount of months, which will be the periods. Okay, so if that is the case, then our I interest rate that we will use for this formula needs to be the monthly interest rate. 12 percent for a year divided by 12 months is 1% per month. And we have 24 months, so that is 24 periods. Okay, now let's see what the question is asking. It wants us how much is accumulated over 2 years. That sounds like a future value, right? That sounds like 2 years in the future, how much do you have? So the value we are looking for here that we do not have is f. Okay, we need an f value and we have an a value. Yes, Clement, you have a question?
Yeah, my question's with the interest rate. So, we have a formula for like the effective interest rate that's like something like a one plus it's like R over C times K minus one or something to the M.
Yes.
When do we use that one versus just like dividing by 12?
So the effective interest rate you're talking about, you can use that. It's
Yeah.
another way of doing it. I, for one, prefer to divide it by 12. Um,
But doesn't it
and
change the interest rate in the end? Like it makes it different?
so the effective interest rate, what it's supposed to do is it's supposed to adjust for the period, right? So
Yeah.
12% interest rate for a year is not the same as 1% interest rate per month. That
Yeah.
calculation won't come out to the same thing. But what the effective interest rate does is it gives you a yearly interest rate that will come to the same as 1% per month here.
Oh, okay. Okay, okay, okay.
So you
I
can make that adjustment, and then your N will be the amount of years.
okay.
I like to keep it simple and just stick to if my interest rate is for a month, then my N should also be for the same period.
Okay, so it either you take it for by month or by year, but you do the effective interest rate.
Yes. Yeah.
Okay, perfect. Okay, thank you.
Okay. So back to what we have here. So we have an A value, right? And we are looking for an F. So we need a formula that converts A to F. So what are the letters we should look for? Should look for F slash A, right? So that's what we're gonna look for. So this is our F slash A formula. So we will say that the F value we want is equal to $40 F slash A at an interest rate of 1% and 24 periods. At this point, I'm assuming you are comfortable with just plug and play with these formulas. So you will plug your values in to this formula, and the calculation comes out to this factor is equal to 26.9. Okay, sorry about that, everyone. Everyone can hear me now, yeah? So now all that is left to do is to find our F value by multiplying 40 by 26.9, and you get a value of $1,076. That's our answer for part A. Okay, now we can do part B. So part B says $30 at the end of the first month, $31 at the end of the second month, and so on and so forth, increasing by $1 per month at 12% compounded monthly. Okay, it's a very similar setup. A lot of things are the same. You have still 12% compounded monthly, which is still 1% per month, right? You have 24 periods. So let's start by writing that information. So I have once again 1% and 24 periods. However, what is different is instead of getting $40 in the month, we get $30 for the first month, and then every other month it increases by $1. So how do we interpret this? So we start by defining an annuity for the $30, which we call it A prime is equal to 30. So what this means is that this is the very first annuity you receive. You get $30 at the end of the first month, and then it's going to increase by one every month. But 30 is the minimum. You know for a fact you will receive at least $30 every month. The amount that's increasing, which here is $1, we represent that by something called a gradient value. The symbol for that is G. And it has a value of $1 because that's the amount it is increasing by. Okay. And we are looking for, once again, an F value. So here we're looking for an F value. We have an A annuity and we have a G. So how do we work with this? Let's see what we have. We have F slash A, but we don't have S slash G. So how can we work with that? Well, look, pay attention to what we do have. We have A slash G. So we can convert this G value into an equivalent A value. And then we can convert that A value into an F. So let's do that. Okay. So first things first, let's calculate our equivalent A value. A, and this calculation will be based on this $30 we have per month, as well as this increasing $1. So this $30 is already in a per month format. So keep in mind this A value will be the amount you receive per month, the equivalent amount you receive per month. This $30 is already just an amount you receive per month. It's already in the correct format. So we will say 30 here, and the rest of the term will be an addition. We do not have to adjust this number. What we do have to adjust is the increasing $1 per month. And that is a G value. We want it in terms of an A. So let's use the A slash G formula at 1% for 24 months, for 24 terms. Okay. Now we can go and check our formula. And this is the formula we will plug in. If you plug in this formula, you find that this A slash G factor is equivalent to 11. Therefore, A will be 30 plus 11, which is $41. So what does this number represent? Basically, all this is saying is that if you receive $30 per month and every other month you gain an additional $1, and that goes on for 24 months, well, at 1% interest, that is the equivalent to just receiving a uniform $41 every month for 24 months. Does that make sense to everyone? That's the equivalent. So now with this value, we can calculate our F value, right? F will be 41. And what is this? This is an A value. So let's use our formula that converts A into F at 1% for 24 terms. This factor equals out to 26.97. It's the same value we calculated earlier. So therefore, our final F value will be $11.06. That is the amount accumulated. And that's the answer for this question. Okay, we can move on to the next question. So the next question is this. A 7% 20-year municipal bond has a $10,000 face value. I want to receive 10% compounded semi-annually on this investment. How much should I pay for the bond? This question is a tiny bit tricky because it requires you to understand how a bond works. But I'll explain that here. So this is question 3.18. So we have a bond. It has a face value of $10,000. And it is 7% and 20 years. If you don't understand how a bond works, think of it as if you were to take a $10,000 loan after an agreed upon time, which here is 20 years, you would be expected to return the $10,000 plus interest. A bond works a tiny bit differently, where you borrow the $10,000 and then after 20 years, you return exactly $10,000. The interest that you owe is paid throughout those 20 years instead of all at the end. Keep in mind, this is compounded semi-annually. So the payments will come in twice a year. That's what semi-annually means. Every 6 months, there will be a payment. So therefore, we have to pay 7% every 7%, which is for a year. So how much of this bond do we owe semi-annually? Well, it will be 7% over 2, which is 3.5%. Every 6 months, you owe 3.5% of 10,000. Okay, how much is that? $10,000 times 0.035 is $350. This bond requires you to pay $350 every 6 months. And then at the very end of the 6 months, or sorry, at the very end of 20 years, you pay an additional $10,000. Okay, so what does that mean in a language that we can understand and analyze? That sounds like you have an annuity, $350 for how many payments? Semi-annually for 20 years, so 40 payments. And After 20 years, you get $10,000. So that's a future value. 20 years into the future, you have $10,000. These are the terms of the bond. Now, it is saying, I want to receive at least 10% on this investment. How much should I pay for the bond? Which basically just asks us, what is the present value of this bond at an interest of 10%? Which again is our nominal interest. Keep in mind how our N is 40. Our N represents semi-annual payments, so every 6 months. So therefore, our interest rate should be 10% divided by 2, which is 5% every 6 months. Okay, now all that's left to do is to calculate the present value based on a known A and a known F at 5% interest rate for 40 installments. Okay, let's start with the annuity. So let's take this $350, convert it to a p-value with knowing that it's an A value at 5% interest rate for 40 payments, plus 10,000 that we will convert to p as it is an F value. So we'll use the p/f notation. Okay. So if you were to do the calculations here with the formulas, since our tables don't go all the way to an n value of 40, the values you get are 17.16 and 0.142. Therefore, your final answer, if you do this calculation, is $7,425.80. This is the present worth of this bond. So therefore, you should never pay any more than this to buy this bond. If you're paying less than this, then it's a good deal. If you're paying exactly this, well, there's no profit, it's zero. But any more than this and you're losing money. Okay, and we're gonna move on to the next question. Question 3.25. It says, Yoko has bought a new computer, $2,000, a printer, $350, and a scanner, $210. She wants to take the monthly payment option. There is a monthly interest of 3% on her purchase. And then it says, if Yoko pays $100 per month, how long does it take to complete her payments? So basically, she's buying items at a defined present value, and she wants to pay with a monthly option. And our interest rate for a month is 3%. Okay, let's do this, keeping in mind that we have to do our calculation by the month. So the interest rate is 3% per month. Now, what is the present value of the items she bought? These listed prices are in the format of present value, so we can just add them up. So P will be $2,000 plus $350 plus $210. If you add these values up, you get $2,560. That is the present value, the present worth of the items she bought. Any way she pays for this, it has to have that same value, right? At 3% interest rate. So it has to match the value. Now, for part A, she wants to pay with $100 per month. And then it's asking how many months will it take to do that. Okay, so her annuity she's paying for is with $100. So the question here is at 3% interest rate, how many months is enough for a $100 annuity per month to be equivalent to a present value of $2,560? So keep in mind we are comparing between a p-value and an a-value. So let's use a formula that allows us to make this comparison. For instance, p slash a. So our present value would be equal to our annuity, p slash a, at 3% interest, but we don't know the n, the amount of periods. So let's plug in what we know. 2,560 is equal to $100 times this factor. Okay, let's substitute our formula. It is 1 plus I to the power of n minus 1 over I 1 plus I to the power of n. That's what I just wrote here. So substituting our known interest rate leaves only n as an unknown. Now, you may be thinking, well, how do we solve for n here? This is a crazy form. This is a crazy amount of math involved here just to solve for n. And I'm not even sure I know how to do it. So how do we solve for n? Well, the textbook tells you to use trial and error. It tells you to guess a value. And based on that value, you run the calculation, you see if the numbers add up, and if they don't, you adjust your guessed value in order to find the value. Yes, Amir, you have a question?
Wouldn't it just be faster to because it's multiple choice, you can just put all the values and whatever equals to 2560?
Yes, exactly. So that's where I was going with it. That
Okay, okay, okay.
uh yeah. So if you don't want to do some crazy math to solve this, and you don't want to spend your time guessing random values and interpolating between them, well, keep in mind your midterm exam is multiple choice questions. So out of however many options, probably uh, probably out of 4 options, you just plug in each one into this formula. You do the calculation here on this side, and you see which value gives you a value of 2,560. So DNF, no, you cannot use logarithm for this to solve for this solution. Logarithm is if you only had 1 to the power of n without a fraction, but this requires some more work. Anyway, if you were to solve this, the value you get is n equals to 50. So on your multiple choice question, this would be the value that gives you the correct answer. Therefore, it will take 50 months for her to pay it off at $100 per month. Let's see part B. That's our answer for part A. Part B. If Yoko wants to finish paying in 24 months, how much will her monthly payments be? So this time, we don't know what the A value is, but they tell us she wants it done within 24 months. So our N is equal to 24. Okay, well, this version is a lot more preferable in terms of solving math. So using the same formula, 2,560 is equal to an unknown P value, an unknown A value, P slash A at 3% interest rate per month for 24 months. Let's see if we can use the table for this one. So we have P slash A, 3% interest rate for 24 periods. I believe we can. No, we can't because we don't have 3% interest rate. Okay. So we have to just calculate it. If you do this calculation, you find that this value here is equal to 0.06. And if you solve for A, which would be 2000, sorry, I was sharing the wrong screen. You find that this value here, this factor comes out to 0.06. So if you take 2,560 and divide by 0.06, you get sorry, just a slight mistake here. I wrote the inverse of the answer, not the answer itself. So this factor should come out to 16.7. So if you take 2,560 and divide by that, you should get an annuity of $154. That is the annuity. That is what she has to pay per month in order to amass a present worth of $2,560 over 24 months. That's it for this question. So now we're gonna move to question 3.27. It says, Seema is looking at an investment in upgrading an inspection line at her plant. The initial cost would be $140,000 with a salvage value of $37,000 after 5 years. Use the capital recovery formula to determine how much money must be saved every year to justify the investment at an interest rate of 14%. So it tells us which formula to use here. But it does not give us the formula in our formula sheet. For this, we have to find it in the class notes. This is the capital recovery formula. It's not, it appears it is not given in your formula sheet, so you may need to know this one by heart. Okay, back to the question. So it says Seema is looking at an investment in upgrading an inspection line at her plant. The initial cost would be $140,000. Okay, let's mark that down. That is a present value because you're paying it right away. With a salvage value of $37,000 after 5 years. So, after 5 years, you receive $37,000. We call that a salvage value. It is in the formula sheet? Yeah, you're right. It's right here. Okay. So forget what I said. You don't need to know it by heart. Okay. It says use the capital recovery formula to determine how much money must be saved every year to justify the investment at an interest rate of 14%. So what is it asking here? It's asking for the value we want is how much money must be saved every year. So whatever value of money we're looking for is in the format of a yearly thing, right? Therefore, it must have the letter A, theoretically. Okay, let's see what the capital recovery formula has. And sure enough, the capital recovery formula gives it to us in terms of a letter A. So that is concurrent with what we would expect. Okay, so it seems the rest of this question is just plug and play. So let's say A is equal to P minus S and then A P at 14%. And what is our N value? 5 years, right? 5. So the question made no mention of how anything is compounded. So we're gonna assume it's compounded yearly. So my interest rate and my N periods will be in terms of years. Plus SI. Okay, let's plug in what we have. So we're looking for A. This will be 140,000 minus 37,000. A slash P, 14% for 5 periods, plus 37,000 multiplied by 0.14, which is the interest rate. Okay, so what does this value come out to? Let's try one more time and see if the table helps us here. And we don't have 14%, but what we can do is we can interpolate. We can interpolate the value, which I will show you how to do that. So just to be clear, we are looking for what is the factor here. What is A slash B, 14% for 5 periods? What is this equal to? We need it because it's in the formula over here. Okay. So let me show you how we can both use the tables and interpolate. So let's look for our A slash P value. For 5 periods, it's 0.2774. 0.2774. But this would be if the interest rate was at 12%. So let's write that that's for 12%. Okay. We need a second data point in order to interpolate, preferably something one lower than 14 and one higher than 14. So let's use 15. Okay. we're looking again A/P for 5 terms. It's 0.2983. 0.2983. This is for 15%. So if I have this value at 12% and this value at 15%, I should be able to calculate mathematically what would be the approximate value at 14%. How do you do that? With the interpolation formula. What is the formula for interpolation? It's y is equal to y1 plus x minus x1 over y2 minus y1 over x2 minus x1. So let's solve it. You should know this formula by heart. It's super useful. So the y value here, which will be for 14%, will be the y value for the first set, which is 0.2774, plus the x for which we're looking for, which is 14, minus the x value of y1, which is 12. And then this fraction is y2, our larger y value, 0.2983 minus 0.2774 over 15 minus 12. And now all we need to do is just throw this into our calculator. I get 0.29. Logically, this makes sense because this value here should be something in between these two values, right? So, therefore, this fraction is equal to 0.29. So once again, this formula for interpolation is very useful if you know it by heart. If you can't manage to learn this by heart and you can't remember it for your exam, here's a formula everyone can remember, but it's a little longer. Just take y equals mx plus b. Everyone remembers how to do this, right? You remember that m was y2 minus y1 over x2 minus x1. That's what we're doing when we're interpolating. Yes, then if you have a question.
Yeah, would you recommend doing interpolation or just use the formula in the previous formula?
So here's what I would do. If you have to interpolate, I would prefer to use the formula. Okay. That's what I would do.
Okay.
Now, here's where using the tables works or interpolating works. For instance, so for example, if you need 6% interest rate, if your n value is in the table and your interest rate is in the table, then you can just grab it there and there's no problem with that. There are some instances where interpolating is worth it to do, and that's if you're dealing with absolute halves. Okay, so if I take, let's see here, let's say 10%, or so let's take 10 and 12%, right? Imagine that your interest rate was 11%. Okay, 11% is not in this table, right? But you have 10%, and you have 11 or you have 12%, right? Notice one thing. Notice how these two values are exactly the same amount apart from 11, right? 10% is one away from 11. 12% is also one away from 11. 11 is exactly halfway between these two values. In that case, to interpolate, all you would need to do is take the average. So for instance, if we want P slash A at 5 years at 11% interest rate, I would take this 3.791 plus this 3.605 divided by 2. It's halfway in between, right? So taking the average will give us the right answer. Does that make sense to everyone? That's a case where interpolation can be pretty quick. Okay. Now back to what we were doing. So we have our formula here. We have our 0.29. So now all that's left to do is to plug it in this big formula and find the rest of the values. If you do that, you get a value of $35,235. And that's our answer for this question. Okay, moving on. Question 3.30. A new software package is expected to improve productivity at Grand Insurance. However, because of training and implementation costs, savings are not expected to occur until the third year of operation. At that time, savings of 10,000 are expected, increasing by 10,000 per year the following 5 years. After this time, 8 years from the implementation, the software will be abandoned with no scrap value. How much is the software worth today at 15% interest? So it wants us to calculate the present worth of this software or the present value. Okay, let's understand what exactly we're dealing with here. Okay, so basically, it is telling us that once we pay the price, we only start saving money by the third year of operation. And then we start saving $10,000, increased by $1,000 per year for the following 5 years. Okay, so let's represent that in a table graph so that it can be clear for us. Okay, so this here is just a time scale in years. And let's go year by year and see what exactly is happening. So right away, year 0, what happens? Well, you pay for the software, right? So that's a down arrow, negative value, because you're paying. That's the initial cost of the software. What happens after that? Savings are not expected to occur until the third year of operation. Okay, just for the record, savings can be represented as savings can be represented as just revenue. Okay, savings and revenue, they're interchangeable when you don't know what you're spending every year. So these savings will just count as revenues. At that time, savings of 10,000 are expected, increased by $1,000 per year for the following 5 years. Okay, so let's compute this now. So keep in mind that starts at the third year. So the first year over here from 0 to 1 should be nothing, right? Then the second year from 1 to 2, there's nothing. Now on this third year, this is where the savings start. So your very first saving is $10,000. Okay, and this is supposed to increase by $1,000 for the next 5 years. So in total, there will be 6 increases. And it will be increasing by 1,000. So this one will be 11,000. This one will be 12,000, 13,000, 14,000, and then 15,000 on the 7th year. Okay. So far, does this time scale make sense to everyone? Does everyone understand how this time scale was interpreted from here? Okay. Now, all that's left is to compute it, right? So if we're taking how much is the software worth today, right? So what that means is it starts at 3, no? Okay, so keep in mind my scale starts at 0, which you should do it in that way to calculate the present worth. But people get confused by this, that the arrow starts at number 2. But keep in mind, this is the first year. This is the second year. So at the end of the second year, you're here. The start of the third year is here. So the minute the third year starts, that's when your savings come in, 10,000. So that's why the 10,000 starts on the number 2, and that people get confused by that. Okay. So for this software, to know what this value is, this p value is, what is this p worth in correspondence to all these savings? Right? It's like basically another way of asking it would be how much should you spend for this software maximum? Okay. Now let's compute this. Okay. So the p value will be equal to all of the increases. So you have, let's try to interpret what you have here. Okay. So you have a prime $10,000, right? And then it increases by 1,000 every term, which we said that is a G value. This is what we have. Okay. How long does this go on for? Well, it's 1, 2, 3, 4, 5, 6 times, right? For 6 years. Okay. What's our interest rate? Question gave it to us. 15% interest. Okay. Let's start by doing what we know, which is to find the equivalent A value, which will again be A prime plus G, converting G into A at 15% interest for 6 installments. Okay. So this will be equal to $10,000 plus 1,000. And what is this factor equal to, it comes out to 2.0. It comes out to approximately 2.1. I believe we can use the table here, right? 15% and 6 installments. This is a rare case where we get it cleanly in our table. A/G, which is the letters we have, A/G. 15%, 6 installments is approximately 2.1. Okay, let's calculate what our A value is. It is $12,100. What does this mean once again? If I promised you $10,000 one year, then 11,000 the next year, then 12,000, then 13, then 14, then 15,000, if I made this promise to you, it would be the same as if I just paid you $12,100 every year for those 6 years at 15% interest rate. Okay. All that's left now. So we have our A value, right? Now we can calculate our present value from this A value. We will go A/P, 15%. Okay, what's my N here? Well, don't overthink it. Just this A, right, still represents 6 installments, right? The number of arrows pointing up. So that will be for 6 years. Okay. And this is multiplied by our $12,100. Okay, let's use our table again. We're multiplying what? 15% interest rate, 6 installments. We want I made a mistake here. We need P/A, right? We did the opposite. So P/A with 6, the factor is 3.784. So it's 3.784 times 12,100. Our present value is $45,786.4. Is this our final answer? Are we done here? Is this our P value? No, there's something we need to consider, right? This value of 45,000 is not P at all. This value gives us the present worth at the beginning of the payments. Where is that? That is right here. So this isn't P. This is P star, let's call it. P star. So what do we have to do? We still have to adjust this to another 2 years, right? We need to make this transaction. So how do we do this? Well, we can take this present value we just calculated, 45,000, and consider that it's 2 years into the future. Calculate the present worth from that, and that will bring us to year 0, the present, right? So let's do that. So our actual p-value will be equal to this $45,786.40. But this is 2 years into the future. So let's do P/F at 15% interest rate for 2 years. Okay, let's use our tables one last time. P/F, 2 years, 15% interest rate, it's 0.7561. Therefore, our final answer will be $34,616.29. All right. Moving on.
Sorry, why was it 2 again? I don't think I heard.
So, why was this number 2?
Yes, why was it 2?
Okay, so this calculation here we did, this P star, we calculated the present value of these annuities, right?
Yes.
The problem with that is the annuities, they only start at this third year. So this present value is at the third year. This formula here that we did, which is good, it works, but it's assuming that the present is this over here, right? So what we need to do now is to take this P star value and bring it to the actual present. And the way to do that is that we find this P value of P, considering that this is the future value 2 years from now.
Okay, thank you so much.
No problem. Can you use the PG right away instead of A prime to A? Yes, you can do that. But keep in mind, so if you want to use P slash G, that only accounts for the G value, right? So you would need to do your P of P slash G plus P slash A. So you can account for that as also with A prime. Is that clear? Okay, now we can move to the next question. 3.34. It says, Gail has won a lottery that pays her $100,000 at the end of this year, 110,000 at the end of the next year, 120,000 the following year, and so on for 30 years. Leon has offered Gail 2.5 million in exchange for all the money she will receive. If Gail can get 8% interest on her savings, is this a good deal? So in this question, you're offered a choice between $2.5 million upfront or the lottery winnings. Which ones would you take? So let's write down what's going on here to make it easy for us. Interest rate is 8%. Let's keep that in mind. Okay, option 1 is $2.5 million upfront, present value. What's option 2? Option 2, you get 100,000 every year, increasing by 10,000 for 30 years. Okay, we know what that is, right? That's A prime is equal to 100,000 and G is equal to 10,000. That's what that means for 30 years. How can we compare these two options in a way that's meaningful to us? Well, we just need to convert them into the same format, right? Here we have an annuity and a G. Here we have a present value. We want to analyze them in a way that where they're speaking the same language, right? In the same format. So since this one is already in a present value, let's keep it that way and let's just convert these into a present value, right? So the present worth of option 1, well, it's just 2.5 million instant dollars, right? And the present worth of option 2 will be whatever this conversion is into p-value. Okay, let's do our same calculation here we've been doing. The equivalent annuity would be 100,000 plus 10,000 A slash G, 8% for 30 years. I believe we can use the tables for this one too, because the earlier tables go down to 30, it looks like. Or only 8% goes down to 30. So if you get 8%, you're lucky. You know you can go down to 30. Okay, A/G, 8%, 30 periods. We get 9.19. This value is 9.19. Okay, let's do the calculation now. 9.19 times 10,000 plus 100,000. $191,900. This is the equivalent annuity. So if you're receiving $100,000, increasing by $10,000 for 30 years, it's just the simple equivalent of receiving $191,900 every year for 30 years. Okay, now we can calculate our present worth of the second option, which is this $191,900, and converting to a P from an A. Let's use our table again. P/A for 8%, 30 is 11.258. 11.258. That gives us a present worth of $2,160,376. Okay, which option do we take? Option 1, you get $2.5 million, or option 2, you get the equivalent of $2,160,000. So $2.5 million is the option you should take, right? It has more value. Okay, so that's it for tutorial 7. Now we have some tutorial 8 to do. Let's go ahead and take a 10-minute break. So at 8:28, we will resume.
Just before you go, lecture 7, which, no, tutorial 7, which lectures does it go over?
So this is supposed to be lecture 6.
Okay. Okay. Thank you.
No problem. Okay, so we will see each other again at 8:28. Okay, just before we start the next session, uh, let me give another 2 minutes if there's any questions you guys have on anything we've covered so far. Okay, so assuming there's no questions for now, let's go ahead and continue. So now we are going into tutorial 8, which is economic equivalency. Okay. So here is our first question. An individual deposits an annual bonus into a savings account that pays 8% interest, compounded annually. The size of the bonus increases by $200 each year, and the initial bonus amount was $5,000. Determine how much will be in the account immediately after the fifth deposit. Okay, so this guy, is doing $5,000 every year, and each time it's increased by $200. Okay, and then we want to determine how much will be in the account at the time of the fifth deposit, which since the deposits are every year, so this will be on the fifth year. What is the future value after 5 years, right? Okay, so we have an annuity of $5,000. We have a gradient of $200 each year. It's compounded annually with interest of 8%. And then we want to know what is the future value after 5 years. Okay. So let's just do this.
Quick question.
Yeah.
It looks like on the diagram it adds $200 every 2 years.
Which diagram are you looking at?
Oh, sorry, that's for the next question.
Yeah.
Sorry.
No problem. Okay. So, uh, all right. So this is what we have, right? Okay, let's solve this the exact same way we've been solving it with the equivalent annuity, which is going to be 5,000 plus the gradient 200, which will be adjusted to be an equivalent yearly. 8% for 5 years. I think we can use our table again. So 8%, year 5, A/G is 1.846. So this is equivalent to 1.846. Okay. The A value then is 5,369.20 dollars. Okay. Now we need a future worth, right? So we can say that the future value or future worth, we'll call it, is this $5,369.20 if we were to turn it into an F value. Again, for 5 years. What is this equivalent to? F over A at 5 years for 8% interest is 5.867. Okay, so now we can calculate what this is. So I take 5,269.2 times 5.867. It's $31,501. This is the final answer for this question. Okay, moving on to question 2. Okay, so it says compute the value of P in the accompanying cash flow diagram, assuming that I is 9%. Okay, so basically what's going on here is that this P value here, which is negative, is supposedly cancels out all of these positive values. So that means that if we take all of these revenues and calculate the present value of that, it should be equal to this P. And we need to find this value of P. Okay. Do you see any trends here? Do you see any? Because, like, yeah, we can just take it each and every value as a future value, convert them one by one to present value. We can do that. Might take a little bit of time. Do you see any trends we can take advantage of? And the answer here is yes, there are. So there's $100 back to back. That's an annuity, right? Of 100 that spans for 2 years. Then you have a $150 annuity that spans for another 2 years. Then 200 annuity stands for 200 years, and a 250 annuity. Now, the reality is we cannot exactly take advantage of this trend because it's just the same amount of work. Because if we take them as annuities, if we take 250 and 250, then we have to adjust it for it being 5 years into the future. And then same with these being 3 years in the future, same with these being a year into the future, right? It gets messy. We're not really saving ourselves some work. And you may be thinking, what about gradient? Is there a way we can take advantage of gradient? Because there is a consistent $50 increase every 2 years. Well, the problem with that is if it's not consistent year to year, our gradient formula will not work. So we can't use that either. So unfortunately, the easiest way to do it is just to go one by one with the years. Okay. So if we take the present value, it's just gonna be equal to, look at this, you get an immediate $100. We don't have to adjust it. It's in the same time frame as this P. So we'll just write that as 100. Then you get $100 a year into the future. So 100 F, sorry, P slash F. Our interest rate is 9%, and this is 1 year into the future. Then you get $150 2 years into the future, another $150 3 years into the future, then $200 4 years into the future, another $200 5 years into the future, then 250 twice, right, on years 6, 7. Okay. And this at this point is just plug and play into either your calculator or your uh, tables. So here's the other thing I was talking about. Our interest rate is 9%. We have interest rates for 8% and we have interest rate for 10%. So the interpolation is easy, right? Because 9% is exactly halfway between these two interest rates. So here's what I'll do. For this term over here, with a P slash F 9% for 1 year, one term, I'll take the value of P slash F for one term of 8, and I'll take the value of P slash F for 1 year for 10%, and I'll take the average between the two, and that will give me my answer. So 9091 and 0.9259. Take the average between them. It is 0.9175. That will be our value for this factor. And rinse and repeat with all the other terms. I won't take the time to do each and every single one of them, but the value you should end up with is $991.31. That's it for our question 2. Question 3. So it says the two cash flow transactions shown in the accompanying cash flow diagram are said to be equivalent at 6% interest compounded annually. Find the unknown value of X that satisfies the equivalence. Okay. Anytime we're comparing between two cash flows, for you to compare them, they need to be in the same format, right? And either that is present worth, annual worth, or future worth. Okay. So if you have them in present worth, that means they're each a p-value, and you compare p-value to p-value, the equivalent p, right? Same with annual worth, you're comparing A to A, so that's like a per year or per month or whatever your time frame is, a continuous uniform payment, or future where you compare F value to F value. Okay. And comparing these will always net the same result. So P if P1 for like if if you're comparing two options and the present value is more favorable on one side, then always the annual worth and the future worth will also be more favorable on that side. Okay. Or in this case, if they are equivalent, as it says, so this cash flow diagram is equivalent to this cash flow diagram, that means whether we take their present values, their annual worths, or their future worths, it will result in equivalency. It will be the same. So basically, in other words, pick one and run with it. Let's go with present worth. It's the most simple. The two cash flow transactions shown in the accompanying cash flow diagram are said to be equivalent at 6% interest compounded annually. Find the unknown value of X that satisfies the equivalence. Okay, so when you're considering 6% interest rate, that's when they are equivalent to each other. Okay, so if this is equivalent to this, and we want to find the unknown X value, how would we go about this? So let's try to see what we observe first, if there's any trends. One thing you definitely notice is that X is a uniform reoccurring payment, right? So that looks like an A. It's an annuity. Okay, we know so this cash flow diagram is pretty simple. It's just a single annuity. Okay, notice how the annuity does not start on year 0. That's because the definition of annuity is always payments you receive at the end of the cycle. So if we're going by years, you get X dollars at the end of the year. That's why year 0 does not have 1. Okay. So would you all agree with me if I said the way we can find X is I can calculate the present worth of this first cash flow, and this present worth should be equal to the present worth of this cash flow. And if I have a present value, then my only unknowns left is my X itself, right? So let's try that. So first things first, let's calculate the present worth of the first diagram. Okay. There's no trends here to be taken advantage of. You can try something with a gradient, but you would have to take 2, right? Because here you have a gradient of -50. Here you have a gradient of +50, so that's 2 different gradients. Here you have a consistent annuity. It's a bit complicated. Let's just take the present value. So you get $200 right away. No need to adjust. You get $150 a year from now. You get $100 2 years from now. Another $100 3 years from now. 150 on the 4th year. And 200 on the 5th year. If you were to compute this present worth, it is equal to $782.7. We said they're equivalent, right? So present worth of the first one is equal to present worth of the second one. Therefore, present worth of diagram number 2 is also $782.7. So these X values give us an equivalent present value of 782.7. Okay. So we can use the A/P formula here, right? Or the way I like to think about it is that you have a present value of 700. You have a present value of $782.7, and that's gonna come from some annuity of value X. So P/A 6%. What's my N number? We have to count how many installments. 1, 2, 3, 4, 5. There's 5 installments. So that's one way to do it. Or the other way would be X, which is an annuity, is equal to 782.7 A from P. 6% for 5 installments. So 5 equivalent installments. I like to do it this way. Okay, what is this equate to? Let's go see in our 6% graph. P/A 6%, 5 installments is 4.212. So therefore, we take 782.7 divided by 4.212. You get $185.83. That is the equivalent value of X. And that's our answer for question 3. Let's do question 4. From the accompanying cash flow diagram, find the value of C that will establish the economic equivalence between the deposit series and the withdrawal series at the interest rate of 8% compound annually. It says it will establish the economic equivalence, meaning your revenues equate perfectly to whatever you're spending. In other words, the present worth of this complete diagram is 0. The annual worth of this diagram is also 0, and the future worth of this diagram will also be 0. So we will need to find what this C value is. Okay. So let's do what we said. So we're gonna consider that first of all, what's our interest? 8% interest. Okay. As I said, present worth of this is equal to 0. Okay, and what is our present worth formula? Let me just redo this diagram quickly. Okay. So it's like 6,000 here, 6,000 here. Here you lose C, you lose C, you lose C. And then you lose C here. That's what this diagram is. Okay, what's the present worth of this if we're calculating it? So if this, we can take this C as an annuity, right? These ones. But if we do that, it will give us a present value here. Okay, that's perfect. So that's great. But if we take the present worth of this here, the present value we get is right over here, right? So if I take P, let's call it P star. Let's take C, P slash A, right? It's a reoccurring annuity for 3 installments. This P star value is 5 years into the future. This is where it comes in. Okay. And if I take the present worth of these two $6,000 values, let's call it P star star, 6,000, P slash A, 8% for 2 installments. This P star star value is over here. So we need to adjust them, right? So just to keep in mind that this P star value is the equivalent of these 3 C's, and this P star star value is the equivalent of these two 6,000s. Okay? So when I do the calculation, I'm not going to repeat the C's or the 6,000, but if I take the present worth which is equal to 0. And I take this, let's start with this term here, the three C's over here. It's C, P slash A, 8% for 3 installments. That term in itself is perfect now, because this term will give us a present worth exactly on year 0, which is what we want. We don't need to adjust it. Okay. Plus, let's do our P star. P star, as you can see, it's 5 years into the future. So we need to adjust it with a P slash F, 8%, 5. This will move the value from 5 years into the future to present day. And then we have to take our P star star and move it back because it is 8 years into the future. Is this clear for everyone so far?
Yep.
If this confuses you at all, practice it a little more, and you can't, if you really can't wrap your head about it, no, this is PF. You're right. If you really can't wrap your head around this, and you've tried so many times, just take it as individual values, P over F on each one of them. No shame in that, but do what you have to do, you know? But this is the quick version. Okay. Now, all we have to do is plug everything in and calculate our value. So first we have C, P slash A, 8% for 3. Then we have C, P slash A, 8% for 3. That's also multiplied by P slash F, 8% for 5. And then plus 6,000 P slash A, 8% 2, P slash F, 8%, 8. Okay, that's our formula. Okay, if you do this, you get 0 is equal to, what's our first term? P over P slash A, 8% for 3. 8% P over A, P slash A, 8%, 3 installments, 2.577. 2.577 C plus, this is the same exact term, so it will be the same, 2.577 multiplied by P of F, P slash F, 8% for 5 is 0.68. 0.68 C plus 6,000 P over A, 8% for 2. P over A, 8% for 2 is 1.8 times P slash F, 8% for 8, P slash F, 8% for 8.54. Okay, let's simplify. I get 4.33 C plus 5,832. Therefore, C is equal to negative $1,347. Why is C negative? Well, that's just because it points downwards and I didn't write it as negative in the formula. So it's showing it that this is definitely a negative value. Since C in this diagram shows pointing downwards, so the negative is implied. So therefore the value for C is $1,347. That's your final answer. Okay. Question 5. John J is purchasing a $24,000 automobile, which is to be paid for in 48 monthly installments of $543.35. What effective annual interest rate is he paying for his financing arrangement? So usually this is normal, like you find the interest rate. Usually it can ask you what is the interest rate. Okay, that's fine. We can calculate that. But now it's taking it another step and find what is the effective annual interest rate. So let's just find the interest rate and then worry about finding the effective interest rate later. Okay. So you have a present value of $24,000. That's the price of the car. You buy it right now. It's supposed to be paid in 48 monthly installments of 543.35. So you're gonna pay it with an annuity of $543.35. 48 monthly installments. Okay. Let's find the interest rate here. Since our n, which is equal to 48, is in months, right? It's representing the amount of months. That means the interest rate we will calculate from this is for a month. Okay, we have $24,000, and that's equal to $543.35 installments at some unknown interest rate if you do 48 installments. What is the interest rate? Okay, what's our formula here? Our P/A formula. It's this. So it is 1 plus I to the power of 48 minus 1 over I, 1 plus I to the power of 48, and that's it, right? On the other side of this formula, you would take 24,000 and divide by $543.35, 44.17. Okay, now solve for I. Good luck solving for I, right? Let's just, in your multiple choice exam, let's just take the choices we have and trial and error them, right? And the value you will find is 0.34%, because the value will be equal to 0.0034. That's the value you will get. Okay, let's find the effective interest rate to have our final answer. Here's your formula for the effective interest rate. 1 plus interest rate to the power of m minus 1. 1 plus interest rate power of m minus 1. Okay. What is m? So IS, the interest rate, is 0.34%. What is m?
The time that you're going to be paying them back for.
Yes, not quite, but m is the adjustment between the two periods, right? The effective interest rate is supposed to be for a year, right? And the interest rate we have right over here is a monthly interest rate, right? So this M is asking the period that this is based on, how many times does it fit into the period that this is based on? Answer is 12. Does that make sense to everyone? Is there's 12 months in a year? 1 plus 0.0034 to the power of 12 minus 1. So again, IS 0.34% is monthly. Effective interest rate is yearly. So how many months in a year? 12. That's your M value. Okay, you can make this calculation now and you get 4.16% interest rate. That is your effective interest rate. Okay. And let's solve one last question, which is question 6. It says, sketch the cash flow diagram associated with the following equivalency expression. And it gives us the expression. That's part 1. Okay, let's focus on that. Afterwards, we have to calculate it. We'll do that. But let's start with this. I have this expression. The present value is equal to 200 P slash F, the interest rate, 1 plus 100 plus 20 A over G I 4. That's multiplied by P over A I to the 4. And okay, this was ends here, the colon, and then multiply once again by P slash F I to the 2. So this one takes a little bit of practice, but I find that once you've done enough cash flow conversions, you can see the trends and find what each formula looks like, right? So let's loosely interpret it, what this means. P, okay. They use the formula P slash F. What does that tell us? That means that they're converting to a P value, obviously, and they have an F value, right? So this 200 is an F value 1 year into the future. Okay. Then we have what's going on here. You have 100 plus 20 A slash G. Does anyone recognize this equation? It's exactly what we did when we convert an annuity, right? A gradient annuity to a series annuity. So this tells me that, look, the first payment was 100. It increases by 20 because that's the gradient, right? So now this whole term, if you calculate it, it gives you the equivalent annuity. And then you have, they take that equivalent annuity, they convert it into a present value. Keep in mind there's 4 installments. And then they take this whole thing and they move it back 2 years into the past, which implies that this whole thing starts 2 years into the future. Okay, let's interpret it this way then. Okay. I stopped at 6 because I can tell that's how long this cash flow diagram is based on it's this term starts 2 years into the future and then it goes on for another 4. Okay. Now first of all, it's saying P is equal to all of this. So there's a P that cancels out everything going up. So let's just do a P value going down. Okay. You get $200 1 year into the future. So you get $200 over here. Okay, that's it for this term. We have no other information on this. So that's how we interpret it. Then, okay, so this we said is a whole annuity, but from this term over here, because they at the end they moved it back to 2 years into the past, we know that it starts on year 2. So something starts on year 2, an annuity. Okay, this annuity by this value here, we know has 4 installments.
Don't we also know it's going to be $100?
Yeah, yeah, we know. So 4 installments. Okay. So, but just keep in mind that these 2 here, since we're going 2 years into the past, it's supposed to start on year 3. Okay. And the reason for that is recall. Don't get confused like I just did and put the arrow on 2. Keep in mind that it starts on year 3. And the reason for that is based on the definition of a present worth. Or sorry, an annuity. See this annuity here, X, doesn't have a line on the starting year. Okay. Because you get the payments at the end of the year. So even though it says 2 over here, you have to start it on 3. Okay. That's it. 4 installments. That's good. What does this tell us? It tells us the first one is 100 and then it increases by 20. So 100, 120, 140, 160. And that is our cash flow diagram. Then it asks us simply to calculate it using an interest rate of 10%. Okay, well, thankfully, we already have the formula written out for us to calculate it. If you're confused about this, if you did your graph and you want to make sure you did it correctly, just do the inverse and try without looking at this formula, write your own formula, your own interpretation of this graph, and it's a way to see if you did it correctly. Okay. So now this is just the same plug and play we've been doing since the beginning of the lecture. So I'll give you the answer. And if you do this plug and play, you get a p-value of $516.15 at 10% interest. Okay, so that concludes this session. That concludes tutorial 7 and 8. And I'm here for any questions that you guys have. Will the midterm questions be the same difficulty as the tutorial questions, or should we expect them to be harder? I have absolutely no clue. I have no idea what will be on the midterm. So I cannot answer that question.
Do you have like a ballpark range of how many questions?
No, I don't know. So yeah, I hope that this will. How long is the midterm? Believe it or not, I don't even know that. Uh, I tutorial 7 and 8 went over the totality of chapter 6. Uh, it's lecture 6. I don't know if that is the same as chapter 6 in the textbook. Uh, it might have some aspects of lecture 7 also, but I'm not even sure because I haven't seen lecture 7. But this tutorial in terms of tutorials, if you understood this and you understood everything the tutorials before this, then you are all caught up at this point. So there's no aspect of tutorial 9 that should be on the midterm. What about lecture 5? I don't know what lecture 5 talks about. Let's go see. Okay, so lecture 5 is the introduction to time value. Yeah, so it's the easier. If you understood everything I just explained in this tutorial, then you know lecture 5 because you need to know lecture 5 to understand anything I just explained. No problem.
Are you briefly able to go over Slack when you're making diagrams for um,
Yeah,
seeing how long things will take?
yeah. So for scheduling, when you have your little box here with the name of the activity, you have your uh, early start, early finish, project duration, late start, late finish, right? And then you have your Slack here. Your Slack, uh, hang on, sorry, I lost my page. So your Slack represents the amount you can delay a project, right? So your early start, if your early start is, let's say, 5 and your late start is 10, which means you can theoretically delay the project by 5 whatever days, years, whatever, then your Slack would also be 5. So Slack is just either the difference between the starts or the difference between the finishes. It's the amount you can delay the project by. Does that make sense?
Yeah.
So basically just take one of these numbers on the bottom, except for the D duration, and minus one of the associated numbers on the top. Okay, does anyone else have any questions? Okay, Mohammed. So, what is the difference between free float and interfering float? So, basically, the free float, is just a simple amount you can delay a project by. So this S value here represents the free float. But if this activity here was dependent on another activity uh, coming after it, right? Or if another activity depended on this activity, so you had some other activity here. I mean, you can theoretically uh, delay this activity for some potential additional time that this activity you can delay by, right? So let me put it this way. Let's call this activity 1 and activity 2. Okay. If activity 1 has a float, right, or a slack, it's the same, of 5 days, and activity 2 has a float of 2 days. If activity 1 is really causing me problems, then I can delay activity 1 for 7 days, for instance, and then start activity 2 right away. But then I have to start activity 2. I can't delay it anymore. So for the case of activity 1, the free float will be 5 days, and the interfering float will be 7 days. Right? 5 is the amount I can delay activity 1 without affecting any other activity. Does that make sense? Okay, so I think I'm gonna go ahead and assume that nobody else has any more questions.